Hey everyone! Welcome to episode 6 of the Awakening 3D Models. Let's take a quick look at what we covered last episode. In the previous episode, we explored bone collections and organized bones into separate collections to keep our scene cleaner. Then we moved on to custom bone shapes and went over how to create controllers in the process. We also added a new constraint to the linkage, bringing a new feature to our rig. Now, in this episode, we're going to dive into two super useful and powerful tools: custom properties and drivers. Don't forget to download the practice files for this episode from Gumroad or ArtStation, and make sure to practice. If you're ready, let's get started. Let's start with custom properties. What? You don't know what custom properties are? Well, I didn't know at first either. Let's do it together and get familiar with it. The custom property is an extra control to make the rig more flexible and easier to use. You can find custom properties in 3 different places in Blender. First, if you go to the Object Properties panel, you'll see a section for custom properties. These properties are useful when you want to control object-level settings, like visibility, transformations, or other custom behaviors that apply to the entire object. The second place you'll find them is in the Object Data Properties panel. These are great when you need multiple objects to share the same property settings. For example, changing a property on the mesh data affects all objects using that mesh, keeping everything consistent. And the third place where custom properties appear is in the Bone Properties panel, which is exactly what we're going to use in this lesson. In rigging, custom properties are super useful for controlling bone behaviors, like switching between IK and FK, setting up constraints, or adding pose-related controls. Alright, to start, I'm going to click on Neck, and then click on New to create a new property for it. Please note that I created this custom property in Pose mode. Yes, it's really important in which mode you create a custom property, but don't worry about that for now. Just remember to create it in Pose mode. As you can see, when we add a new custom property, a new tab appears here, and that's where our property is stored. By default, it comes with some basic settings, but we need to adjust it to fit our needs. You can remove it by clicking the X, or open its full settings by clicking the gear icon, which gives us complete control over customization. The first thing we need to set is the type of our property. The type defines what kind of data this property is going to hold. Choosing the right type makes sure everything works smoothly in our workflow. From this list, we can use either float or integer. The difference? Float allows decimal numbers, while integer only works with whole numbers. You can pick whichever suits your needs, but for our case, float is the right choice. Float can store decimal values, which makes it perfect for precise controls like movement, rotation, weight, and more. Now let's enter a name for our property. I want to use this property to control the neck rotation around the x-axis. So I'm going to name it neck_x rotation. Next, we have the default value. The default value is the starting number assigned to this property. If you ever want to reset a property to its default, just hover over it and press backspace. Choosing the right default value is super important. For example, if you're controlling scale, never set the default to 0, because that can mess things up, as you can see. But since we're controlling neck rotation, setting the default to 0 is perfect. It keeps everything in its default position. Below the default value, you see 2 fields for min and max, which are also called the hard limit. These set the absolute boundaries for a property. The numbers you enter here mean that any value outside this range isn't accepted. I want to draw your attention to an important point in Blender. Angle changes and rotations are measured in radians. That means you can't use degrees here. We can't use -180 for minimum and +180 for maximum. Instead, we need to use their equivalents in radians. Let's stick with these basics for now, and we're going to cover more advanced details later. For now, just know that 180 degrees equals 3.14 radians. So set minimum to -3.14 and maximum to +3.14. After minimum and maximum, you see the soft limit. If I turn this on, I can set another range for the property. The soft limit creates a smaller range inside the hard limit. Basically, it lets us define a preferred range for the animator. So, we have 2 types of limits: hard limit and soft limit. The hard limit restricts all values to a set range, and the soft limit narrows that range further, giving us a recommended range for our custom property. Alright, I'll turn this off for now. Next, we have the step setting. Step determines how much the property's value changes each time you adjust it. It's especially useful when working with sliders, helping to control precision. For example, if I set the step to 5, each adjustment moves by 0.05. If I set it to 500, it moves by 5. With that in mind, setting it to 5 seems like a good choice. Next up is precision. This controls how many decimal places are displayed in the interface. It helps you decide how finely a property can be adjusted and displayed. Now let's talk about subtype. This option only appears if you're using a float or float array. Subtype lets you define the specific category of the property, which helps fine-tune how it behaves and looks in the user interface. But here's something important. Make sure the unit of your subtype matches what you're controlling. Otherwise, things might not work as expected. Since we're controlling neck rotation, we need to match its unit with the rotation unit in the transform menu. But as you can see, this property isn't set to degrees by default. So, I'm going to open the rotation mode menu and choose one of the Euler modes. I won't go into too much detail here. Just look at which axis isn't really used in the rotation and pick a mode where that axis is in the middle. For the neck, we don't need to rotate around the z-axis, so I'm choosing XZY Euler mode. Now back to our property settings. And you see, the settings are back to default. That's because if you click outside this window, it closes. And since we didn't click OK, the changes weren't saved. I'll enter the previous settings again. Okay, since we've set everything up for rotation in degrees, I'm going to select angle as the subtype. In the description field, you can write notes about this property. This can be really useful when working with it later. Alright, we've successfully created our first custom property. I'm going to click OK to apply the changes. The reason this number changed to 57.3 is that before setting angle as the subtype, the value was in radians, and now it's converted to degrees. I just need to hover over it and press backspace to reset it to the default value. But we're not done yet. As you can see, changing its value doesn't actually do anything. That's because we haven't connected it to anything yet. In other words, we need to tell Blender to use this property to control the X rotation. And this is where drivers come in. Drivers are a powerful tool that let you create dynamic relationships between different properties. Basically, a driver takes the value from one property and uses it to control another, allowing for complex automated behaviors without manually keyframing everything. To add a driver to any property, just hover over it and press Ctrl D or right-click and select Add Driver. Either way, this window will pop up. Now be careful. If you move your mouse outside this window, it'll close. And if you press Ctrl D again to reopen it, you'll accidentally add a new variable to the driver. Instead, just right-click the property and select Edit Driver to reopen the settings. If you ever need to remove a driver, right-click the property and choose Delete Single Driver. Be careful. If you select Delete Drivers, it'll remove all drivers in the rotation section. The same applies to location and scale properties, so make sure you're deleting only what you need. Now let's change our workspace a bit for easier access to the drivers. Move your mouse cursor to the top left corner until it turns into a target icon. Then right-click and a window will pop up. Choose the first option, and the mouse cursor will turn into a separator. You'll see a vertical line moving with it. This means that whenever you left-click, a new viewport will be created. If you want a full explanation of this, check out episode 12 of Season 1 of Blender Story on our channel. Now let's click in the top left corner to open the Editor Type menu. From here, select Drivers. Next, right-click on X Rotation and choose Add Driver. Now our driver will show up in this section, and we can easily access and control it. You'll also see the graph editor here, but we don't need that for now. So I'm just going to drag this window and make it a bit bigger. On the left side, you can see the list of drivers created for the selected bone. On the right side of this window, you'll see several tabs. We'll be working with the driver tab for now, so let's click on it to open the settings for the driver we just created. In this window, we'll customize the driver settings. The type setting determines how input variables are processed to calculate the final value of the driven property. If you click on it, you'll see different types of drivers. But for now, you don't need to learn all of them. What we need right now is just the scripted expression. Scripted expression allows you to use custom Python code to define how the driver variables affect the driven property. This is the type we're going to use most of the time. The driver value is the calculated result of the driver's setup. It's mainly for debugging. helping you make sure the driver is working correctly. This field lets you write a custom Python expression to decide how the input variables affect the driven property. To make these connections, drivers use variables to refer to specific data, like object transformations or custom properties. Adding and setting up these variables is an essential step in creating a functional driver. To create a variable, just click on Add Input Variable. You can add several variables, but I recommend not doing that until you're comfortable with how it works, because it might get confusing. To remove a variable, simply click the X next to it. Now we have one variable, and it has several parts that ask for information. In this section, we can set its name. The variable names need to follow specific rules to work properly in Blender. The first rule is that the name must start with a letter. For example, I can name it var1, but if I put one at the beginning, I'll get an error, and the driver won't work. The second rule is to avoid using spaces or periods in the name. In other words, use underscores for spacing. Otherwise, you'll run into errors again. So I'll name this variable nec_var, and I'll enter the same name here. Be careful. When you change the name of the variable, make sure to update the name in this section too. This is important because the expression is the one calling your variable and telling it what to do. If the names don't match, or if the name isn't defined here, you'll get an error. Next to the name field, there's a window where we need to specify the type of the variable. For now, we're going to use single property. A single property refers to a specific attribute of a data block, like an object's location or a custom property. In this section, we have ID type, which defines the type of data block. Next to it, there's the ID, where we can use the eyedropper tool to select something in the scene and link it to the driver. I'll select the eyedropper and choose Luxo Rig. In this part, we need to enter the path of the custom property. There are two ways to do this. We can hover over the nec property, press Ctrl-Shift-C to copy the data path, and then paste it here with Ctrl-V. Alternatively, we can right-click on the nec property and select Copy Data Path. Great, now I'll click Update to make sure the changes are applied and there are no errors. The exciting moment has arrived. From now on, any data you give to the nec property, the next X rotation has to follow it. Let's test it out. I can click here and enter the desired angle. Awesome! By clicking and dragging, we can smoothly adjust the change. I'll press backspace to reset it back to the default value. Keep in mind, once you apply a driver to a property, you won't be able to change it directly anymore. If I click on the X rotation of the nec, we can see the expression code here. If we enter a number here, we're actually changing the expression code, and the driver settings will break. So, I'll copy nec_var again and paste it in the expression field. Well, the first operation is completed successfully. Now we can create the next custom property to control the rotation of the shade. To access the shade, I go to the Bone Collection section and enable all bones. I click on the shade, and as we know, its Z-axis is pointing upwards, so the rotation will occur around the Z-axis. I click on the neck again and create a new property in the Bone Properties section. I click on the gear and go into the settings. I leave the type as float and change the name to shade_Z rotation and set the default value to 0 and the hard limit from -3.14 to +3.14. Set the step to 5. Lastly, I set the subtype to angle. I'll click OK and I'll press backspace to reset its value to default. That's it for the second custom property. Right now, I'll right-click on it and copy its data path. Click on the shade, go into its settings, and set the rotation mode to XYZ. I right-click on Z rotation and click on Add Driver to create a driver for it. I select the created driver here to proceed with the settings. I name the variable shade_var. I'm going to add the same name in the expression field too. I change the type of the variable to single property. With the eyedropper tool, I link the Luxo rig and paste the shade property path that we copied earlier here. Now I press Update to apply the changes. Lastly, to test it, I go to the next settings, and to our amazement, when we change the shade property, the shade bone rotates around its local Z-axis. I'll adjust the view a bit so we can see it better. Great! But it's not over yet. When we change the shade property, the shade rotates and works correctly, but our custom shape doesn't move. To see this change on the CS neck, there are two ways. The first way is to create a driver for the Y rotation of the neck to follow the shade property. But this is not the right approach, because in this case, the neck will rotate, and that's not what we want. The second way is to go to the CS neck settings and create a driver for the YCS neck rotation to follow the shade property. In this case, only the CS neck will rotate, and it won't affect the bone. So I right-click on Y rotation and click on Add Driver. We see that a new driver for Y custom shape rotation has been added here, and by clicking on it, we can go to its settings. I change the type to single property. I name it YCS_neck_var. I copy it and paste it here as well. In this section, I select Luxo Rig. I right-click on the shade property and select Copy Data Path, and then paste it here with Ctrl-V. I press Update to apply the changes. Now you can see that when we change the shade property, the CS neck rotates as well. It's amazing. I make a few adjustments in the CS neck settings, so it controls both the neck and shade. By combining custom properties and drivers, you gain precise control over rig behavior, making animation workflows smoother and more efficient. These tools help automate complex tasks, reducing manual keyframing and making rigs more user-friendly. Practice setting up your own properties and drivers to fully understand their potential, and stay tuned for the next episode as we continue expanding your rigging skills. If you have any feedback or suggestions to improve the tutorial, feel free to write them in the comments. You can also join our Discord group through the link in the description, where any questions you have will be answered as quickly as possible. I hope you've enjoyed so far. Thank you for being with us in this episode, and see you later.